Hello?
Yes,
Please
sir.
respond with me, students. Okay, then S, and S. That is also common prefix problem. Is it?
Yes, sir.
S. But there is no S. That means these this BSSA, BSSA. So this part actually common for this two production rule. Is it?
Yes,
Yes,
sir.
sir.
Yes. But just a minute. But BS actually is common for three production. This one. So BS,
Yes,
BS, and BS. But if you consider BSSA, then it is common for two. But if you consider BS, then it common for actually three. Is it? So always try to actually take the more number of production. So it try to use the three. Okay. Then longest prefix. So you need to consider these three. Then longest prefix. And what is the longest prefix now? There is BS. Is it? Everyone?
Yes, sir.
Yes, and this is very important. Suppose you consider this one, these two, no problem. Ultimate answer will be the same, but this one requires more actually operation to actually to do this work. So it's better to take more production rule at first. That is actually the three. That is actually this one. That is actually this one, and this one. And now the common is BS. Is it? The common is BS. Is it? Hello?
sir.
বুঝি নাই, sir. বুঝি নাই, sir. Could you repeat again, sir?
Yes. Which thing you didn't understand? Please tell.
Yes, sir. Last যে কথাটা, sir. বুঝি নাই কিছু।
So you need to actually take these three. Okay, three. And if you take these three, then BS is the common. BS is the common prefix for all. Is it?
Yes, sir.
But it is also possible. It is also possible by taking. It is also possible by taking this one and this one. That time BSSA, this part is common prefix, BSSA and BSSA. But it's always better actually to take more production. That is this one, this one, this one, and this one. After actually considering more and more, then you need to consider longest prefix. Now what is the longest prefix? That is the BS. Now
Okay,
BS
sir.
is the longest prefix. Is it?
Yes, sir.
Yes, sir.
Okay, got it, everyone?
Yes, sir.
Yes, sir.
Where is Tohit? Tohit is present in the class.
Yes, sir.
Shojib, present.
Yes, sir.
So got it? What I want to say?
Yes, sir.
Yes, sir.
Okay. Then Farshid is present in the classroom.
Yes, sir. Yes, sir.
Yes. How are you, Farshid?
Fine, sir.
Okay, so if you consider the formula like this one, that means actually this is actually A. This is actually A. And the common prefix, this one is alpha. This one that means alpha is BS. Alpha is BS. Alpha is BS. That means AAS, that is actually beta 1. That is actually beta 1. Then SASB, that is actually beta 2. And B, that is actually beta 3. Is it? And there is no common prefix. That means this one actually gamma. Is it?
Yes,
Everyone?
sir. Yes.
Okay. So look at this. So A to alpha A dash, then gamma. Okay. So if A is absent, that is considered as gamma. So please try to understand. If A is absent, and here A actually is sorry. If alpha is absent, that is gamma, not A. So here actually alpha is BS. So there is no BS. That means this one actually gamma. Is it? Is it? Hello?
Yes, sir.
And there can be more than one gamma, like gamma 1, gamma 2. Okay, there can be more than one gamma. No problem. Alpha absent means gamma. Okay. So the first one is actually A to alpha A dash. And what is A? That is S. So S to alpha. What is alpha? BS. Then A dash, that is S dash. Is it? Everyone?
Yes, sir.
Yes.
Yes, sir.
Then you need to write the gamma. And what is gamma? That is A. So if you have more than one gamma, then you need to write like this. Okay? And gamma
Yes,
means without alpha, that is actually gamma. Okay. Then S dash, then S dash 2, that means A dash. That is S dash 2 beta 1, beta 2, dot, 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 beta n. So that is actually S dash 2 beta
Sir?
1. Yes?
Sir, here A will there will be A, not alpha.
Yes, yes, there will be A. Sorry, there will be A. Thank you, Isha. Okay, there will be A, not alpha. Yes. So S dash 2 beta 1, beta 2, and that means S A S. Then beta 2 is equal to S A S B. Then B. Is it? Everyone?
Yes, sir.
Everyone? Yes. But there is again there is a problem of actually a common prefix. So look at this. SA. So there is a problem of common prefix again. So you can consider this one as alpha, this one as A. That means this one is beta 1. This one is alpha. This one is beta 2. That means this is actually this one actually B. So this is actually gamma. Is it? Everyone? Everyone?
Yes, sir.
Yes. So the formula is A2 alpha A dash. And what is A? That is actually S dash. Then S dash to alpha. And what is alpha here? SA. And A dash. So what is A here? What is A here? What is A here?
S.
Is S A.
No,
Is
no.
S dash.
S dash. S dash is the A here. Is it, Isha? Here S dash is the A. So the formula is A dash. That means S dash then dash. That means S double dash. Is it?
Yes, sir.
Actually S dash means a new non-terminal. So you can write like A, that is also okay, no problem. That means you need to write a new non-terminal that is not present in the grammar. That is okay. So that's why I use H double dash. So if you can use like capital letter B, capital letter C, D. That means that non-terminal currently is not present actually in the existing grammar. That means it's a new non-terminal. So here double dash is used to indicate a new non-terminal like that. Okay. So you can use, if you have problem with S double dash, you can use like a new non-terminal, and you can make a new non-terminal, no problem. Okay, got my point. Okay,
Yes,
but
sir.
I think I think this one is easy because this one is very you can relate with the formula like S dash, that means S double dash. But if you want to bring a new non-terminal, that sometimes it will be difficult for you. Okay, so then actually A dash, and A dash actually S double dash to beta 1 beta 2. So beta 1 is A S, then S, then what is it? That is
Sir,
SB.
S এর পরে হচ্ছে B হবে না এখানে?
Sorry.
স্যার S সিঙ্গেল ড্যাশের ওই লাইনটাতে S A
Yes,
S ডাবল ড্যাশ B.
yes, that is okay. So I want to actually there is answer. So as here I am writing, it is like messy. So just a minute, the answer is on the slide. Abu Bakr Abdi is present in the classroom. Abu Bakr. So this is the answer. So any problem, please ask. Hello. So here at first we try to solve the problem of common prefix problem, but at the first step it is not actually enough. Then we need to again actually perform left factoring to solve the problem of common prefix problem. So if you need more step, then you need to perform more. You need to actually take help of more step. Okay, it is not fixed. If you need more step, then you need to actually use more step. Like that. Got it, everyone? Hello.
Yes, sir.
Yes,
So
sir.
So any question, please ask. If you have any question with this one, please ask. No question? Should I proceed and new topic?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir. Yes, sir.
Okay. So top-down parsing actually. So actually top-down parsing actually top-down parsing actually a parse tree for the input string. So actually look at this. So it's a top-down parser because from here to here. That means it starts from bottom. Sorry, it starts from root, not bottom. Just a minute. So it starts from root to bottom. It is a top-down parser. So it's actually it is used actually to generate a string, is it? And the string is id plus id into id, like that. Is it? Hello? So it's actually top-down parser, and it starts from root, and this one is used to actually generate an input, that is id plus id into id. Is it? Hello?
Yes, sir.
Am I audible? So got it? So this one actually a top-down parser which starts from root, and this one is used to generate input string. Is it? Hello? Are you agree with me? Are you agree with me?
Yes, sir.
Hello? And look
Yes,
at
sir.
this. So I think you know about DFS or pre-order, DFS or pre-order in data structure, pre-order, in-order, post-order, and DFS, BFS. You know about DFS, depth first
Yes,
serve.
sir.
Okay, so if you think about DFS also actually looks like this. This one, DFS. So actually top-down parser actually follow pre-order or depth first. Okay, that means it will go to the depth, then actually like that. Okay, so this is the traversal of top-down parser. Okay, just a minute. Okay, this one done. Okay, top-down parser done. Okay, so suppose this is your actually input string, and this is your grammar. So you need to generate this input string with the help of this grammar, and this grammar is left recursion free and left factoring free. Okay, there is no common prefix problem, and there is no actually left recursion. Okay, so you need to generate this input with the help of this grammar. Okay, so I think you are able to generate. So this is the actually generation, and actually here we use leftmost derivation. LM means leftmost and RM means rightmost. So there is actually every step to generate the actually parse tree, and this is the ultimate. So the ultimate is enough. If in exam hall parse tree actually will arrive, then if you draw the ultimate parse tree, that is enough. No need to show each step. Everyone got my point? No need to show
Yes, sir.
every step.
Yes, sir. Yes.
Only the ultimate, only the final parse tree is enough to answer. Okay, got it? Got my concern? So I think you are able to answer this one, because I already discussed how to draw parse tree. Okay. So now top-down parsing, and this is very important. Fast and follow. And fast and follow is the last topic of this chapter. Okay. So fast and follow. So if you think about predictive parser, everyone please respond with me. If you think about predictive parser, backtracking is needed or not? About predictive parser, if you think about predictive parser, backtracking is needed or not? Hello?
Sir, don't know.
So if you actually think about predictive parser, backtracking is needed or no? Yes or no? Backtracking. if you think about predictive parser, backtracking is needed or no? Yes or no? Hello?
Sir, we don't
I
know.
don't know the answer.
Why you don't know? Because I discussed in the last class. So predictive parser without actually backtracking. Okay, so predictive parser don't need actually backtracking. Okay, so if you want to construct predictive parser, a parsing table is created. If you want to construct predictive parser, then you need to actually construct a parser table. Okay, and if you want to actually construct a parser table, that time you need the help of fast and follow. Actually, fast and follow are actually functions. Fast and follow are actually special functions, and those functions actually are needed to construct parser. Is it? So fast and follow actually functions. Fast and follow are two functions, and those functions are needed to construct parser, top-down parser or bottom-up parser. And those functions are also needed to create parsing table. Everyone? Hello? Hello? Am I audible?
Yes, sir.
But why nobody actually responds with me? Please, some students, please unmute and respond with me. Hello? Some students unmute and respond with me.
Okay, sir.
Okay. So fast and follow is very important for your final exam, and those functions actually is needed to create parser, top down or bottom up parser, and those functions are also needed to create parsing table. Is it, everyone?
Yes, sir.
Okay. So there are some rules. There are some rules to find out fast. But I will actually give some example to explain those rules. Okay. So fast and follow is very important because predictive parser no backtracking. That means you need to actually identify what is the next character of this character, what is the first character of this character. So this is very important. So just look. And before finding out fast and follow, the grammar should be left recursion free. The grammar should be left recursion free and common prefix problem free. That means there is no left recursion and there is no common prefix problem. Then you are able to find out fast. Okay, if there is actually a common prefix problem or if there is actually left recursion, then you are not able to find out fast and follow. So your grammar should be left recursion free and common prefix problem free. Everyone?
Yes, sir.
Okay. Okay, so think about. So A to A, B. So this is the production rule, and my question is, what is the first of A? And one thing you need to know, only the non-terminal has first value. Only the non-terminal has first value. Okay, only the non-terminal has first value. So A. So my question is, this is the production rule. Then what is the first of A? So from A we can go A, B. Is it? From A we can go AB. Is it?
Yes, sir.
Yes. So this one, the leftmost one, is it terminal or non-terminal?
Terminal.
Terminal. If the leftmost one is actually non-terminal, sorry, if the leftmost one is terminal, that means this is the first value of A. So this is the first value of A. Okay. So this is the first value of non-terminal A. Got it, everyone?
Yes, sir.
If the
Sir.
left, yes. Hello. Hello. Maybe someone tried to say something, please. Hello. Should I continue?
Sir, okay, sir. बोलना है. Continue.
Okay. So if the leftmost value is a terminal, then this is the first value of non-terminal A. Okay, done. Okay. Okay, just a minute. Okay, so from A to, suppose we can go A or epsilon. From A there is two path. There is two path from A. That is A and epsilon. So you need to consider both. So if you consider A to A, what is the leftmost? What is the leftmost?
A.
A. And A is terminal or non-terminal?
Terminal.
A is terminal. So A is the first value. Then you need to consider this one. So that is A to epsilon. And leftmost is the epsilon. And epsilon is terminal. So this is also the first value. Okay?
Okay.
Okay. Now consider this production rule. From A to, we can go first bracket, lower. Normally uppercase is used for non-terminal and lowercase actually used for terminal. Normally in production rule or in grammar, normally uppercase letter actually is used for non-terminal and lowercase is used for terminal. Okay, so from A to, you can go first bracket, lowercase a, uppercase b, then closing first bracket and or epsilon. Then what is the first of A? Someone please.
Sir, starting first bracket.
So okay, so this is the option, this is another option. Okay, so if you consider this one, so this one actually, the leftmost is actually opening first bracket or left first bracket. Is it opening first bracket?
Yes, sir.
Yes.
Yes,
So
sir.
this one, an opening first bracket is the terminal. So this is actually the first of A. Okay. And if you consider this one, then epsilon is also first of A. Got it? Everyone?
Yes, sir.
Okay. Okay. So now, and tomorrow is your exam. Don't forget that. So look at this. So my question is, what is the first of A? What is the first of A? This is my question. Abu Bakr, present in the classroom. Abu Bakr?
Maybe not, sir.
Okay. So first of A. So if I want to find out first of A, that means I need to look at the leftmost one.
Yes,
Yes.
sir.
Yes.
Yes,
And
sir.
this one is terminal or non-terminal.
Non-terminal.
Non-terminal, sir.
Yes, and non-terminal cannot be first. So you
Yes.
need to find out first of T again. You need to find out first of T. That is this one. First of T. So at first you get that is actually T actually non-terminal. That times you need to find out. You need to find out the first of T. Is it? Okay. And now consider the first of t. And first of t is actually star, because this leftmost one is terminal. So first of t is star. So in this case, first of a and first of t is same. Okay. In this case, first of a and first of t same. Okay, everyone.
Okay, sir.
Okay. So
Sir.
yes, please.
এই ক্ষেত্রে যে ফার্স্ট অফ a ইকুয়ালস টু ফার্স্ট অফ t লেখা তারপরে t এর ভ্যালু যেটা হবে ওটা দিতে হবে।
Yes, and for this case, first of a and first of t same. Okay.
Okay.
But now there is a problem. Just a minute. Okay, just a minute. Okay, now think. So now my task is find out first of a. Now my task is find out first of a. So if I want to find out first of a, that means I need to look at the leftmost one. Is it? And this one is non-terminal. That means I need to find out first of t. That is the first of t. And what is the first of t? What is the first of t? Hello?
Asterisk
Star and epsilon.
Asterisk and epsilon.
Yes, sir.
Yes. So you get first of t directly. So if you can determine first of t directly. But if you think first of a, that means you need to take help first of t.
Yes, sir.
Yes. So if there is a epsilon, so this one is a problem. So this one is problem for indirect. So first of t no problem, because we get first of t directly, and there is epsilon, so no problem. But we get first of a indirectly, and there is epsilon, so this is a problem. We get first of a indirectly, and in first of a there is a epsilon, so this is a problem. But we get first of t directly, and there is epsilon, so no problem. But if you get first indirectly, and in first there is epsilon, so this one is a problem. Got my point? Now I am trying to solve this problem. Okay. Hello.
Okay, sir.
Okay.
Yes, sir. Okay, sir.
Okay. So think. So first of t actually. So now first of a and first of t is different. So you get first of t directly, and there is epsilon, so no problem. But you get first of a, and there is epsilon, so that this actually a problem. And for this case, first of a and first of t is not same, they are different. And how they are different? So first of a, that means ta. So
Sir,
yes,
how will we understand that different? They are different. In
So-
previous case,
Yes.
we see that first of a and first of t. You said
Same.
that asterisk.
yes.
They are same.
Okay. In previous case, the first of t only the star. Yes.
Yes, sir.
Yes. So there is no epsilon. So that's why the first of a and first of t is same. When you get first, suppose here I get first of a with the help of first of t, and at the first case there is only asterisk. So that case there is no problem, because there is no epsilon. That case first of a and first of t same. But now there is a epsilon. So and we get first of t directly. So if we get first of t, if we get first of any non-terminal and there is epsilon, so there is no problem. But if I get first of any non-terminal indirectly and there is actually epsilon, so this is a problem. So here I get first of a indirectly with the help of first of t, and there is epsilon. That's why the first of a and first of t is different. And how and what will be the first of a? This is my concern now. Okay.
Sure. So basically, if there is any epsilon, then it would be problem.
Yes.
Okay.
But this one is not problem for t, because you get first of t directly. You don't need the help of another non-terminal to get first.
Okay,
So this
sir.
one is no problem. Okay.
Oh, I got it, sir.
Okay. So now how we will get the first of A? So you need to replace. So if you think first of A, so you need to go here, and here is actually non-terminal. And what is first of T? That is actually into. So you need to replace. You need to replace these this non-terminal with star. So if you replace this non-terminal with star, that means the first of A is star. Is it? Because star is non-terminal. Is it?
Yes, sir.
Yes.
Yes, sir.
Then again, you so there is two first. So at first you replace non-terminal T with star. Now you need to replace non-terminal T with epsilon. So okay. So now you need to replace non-terminal T with epsilon. And when you replace non-terminal T with epsilon, that time this T will be removed. Is it? This T will be removed, because if you replace anything with epsilon, that one will be replaced. That one will be removed. Okay. Hello.
Okay,
Yes,
sir.
sir.
Okay. So this one will be the removed. Then what is the first of A? What is the first of A?
A.
A. So this is the first of A. So this is the difference. So now this is the first of A. That is actually star and A, and the first of T star and epsilon. Got it?
স্যার এই যে টি রিমুভ যে হলো ওটার পার্টটা আবার বুঝাবেন
Yes. Okay. So now you are trying to find out first of A, because now first of A and first of T is different. So and T is actually a non-terminal, so you need to replace this T with first of T. So at first you replace with star, no problem. But when you replace this T with epsilon, that looks like epsilon A. Is it? Isha?
ইয়েস স্যার
Yes. And we know that if epsilon is single, that time we need to write epsilon. Otherwise, don't need to write epsilon. Is it?
ইয়েস স্যার
Okay. So actually, this one actually like this one. So A to A. So this is the first of A. That is small a, because when you go actually here to here, you will get only A. So this is the first of A. Okay.
ইয়েস স্যার
Okay. This concept is clear to all of you.
Yes, sir.
Okay. So
Yes,
now just try to solve. Okay. So now my question is, what is the first of E? What is the first of E? That means I need to go leftmost one. Just a minute. First of E. Then what is the? We need to go to here. Is it? Hello.
Sir. Yes, sir.
Yes. And this
Sir.
one is terminal or non-terminal. So look at the grammar. This one is terminal or non-terminal.
Non-terminal.
So I need to find out first of T again. Then first of T, that is actually this one. So F is terminal or non-terminal. Look at the grammar.
Non-terminal.
Non-terminal.
So I need to find out first of F. First of F. So now, so this one actually terminal. So this one is the, and there is another one, that is ID. ID is terminal or non-terminal here? For this grammar, ID is terminal or non-terminal?
Terminal.
Terminal.
That's why the first of F is opening first bracket and ID. That means the first of F equal to first of T and equal to first of E. Got it, everyone?
Yes, sir.
Everyone?
Yes, sir.
But suppose there is actually the first of F is opening first bracket, ID and epsilon. That time first of A, no problem, because we directly get this one. But first of E and first of T will be different, that case. Okay. Is it? Hello? Is it?
Yes, sir.
Everyone? Got it, everyone? Suppose first of A is opening first bracket, ID and epsilon. So first of F, no problem, because we get first of F directly. But if you think first of E and first of T, that is not this one. There is some changes. Okay, everyone.
Sir, what about first of E prime?
ওটা আপনি আস্তে আস্তে বের করলে আপনি বুঝবেন। আমরা তখন এই কয়েকটা বের করলাম, বাকিগুলো বের করব। So we mainly actually find out first of non-terminal. And how many non-terminal here? How many non-terminal here? Yes,
5.
5. So we find out 3 non-terminal. First of 3 non-terminal. Now this one and this one we need to find. So think about this one. So just a minute, I need to actually erase. So think about this one. So there is 2 production rules. So E dash 2 plus. So plus is terminal or non-terminal for this grammar? Terminal. So at first of E actually plus, then E2 epsilon. And epsilon, this one is the first. Okay, got it?
Yes, sir.
And first of T dash. So this one is so if I want to find out first of T dash, that means I need to go the leftmost one, and leftmost one is asterisk, and asterisk is terminal or non-terminal?
Terminal.
Okay, so that's one, and there is another production rule. That's why T dash to epsilon. So
Yes.
this one actually also first of T dash. Done, everyone?
Yes, sir.
Yes, sir.
Any problem, please ask. Hello? Any problem, please ask.
No problem, sir.
No problem. Acha, so those things actually there, no problem. There is also those things actually also describes here, no problem. Okay, just a minute. So if you look at a grammar, so where the number of actually non-terminal actually more, bottom or top, number of non-terminals?
The
Top, actually, yes. If you observe a grammar, number of non-terminal actually more in the top section, and number of terminal actually less in the actually bottom section. Is it? That means more terminal here, and always it's easy if you find out first from bottom to up. Okay, that means bottom to top. So okay, because there is less actually non-terminal, there is less non-terminal on the bottom. That's why it is easy to find out the first of the bottom production rule. Okay, so this is the what is the first of F, that is actually this one and this one. And what is the first of T? That is this one and this one. What is the first of T? That is actually first of F, and first of F is already calculated, so this one. And what is the first of E dash? That is plus, that is epsilon. And what is the first of E? And the first of T actually already calculated. So it is easy if you start from bottom to top at the time of finding first value, because bottom section actually contains less number of non-terminal and more terminal. Okay, and we know that terminal can be only terminal, and epsilon can be actually first. Non-terminal cannot be first of non-terminal, but the value is not non-terminal. Okay, everyone got it?
Yes, sir.
Yes, sir.
So if you have any question, please ask.
আরে ফলো রোতে এগুলা কি?
Okay, this is the next class. Okay, and this is the last one. Okay,
Yes.
so if you don't have any question, then I will start the review class. Any question from today lecture?
No, sir. No, sir.
But there is 32 students in the classroom. I don't know why, but that is not my actual issue. Okay, so আপনারা হচ্ছে আপনাদের কি মানে 4-5টা বিষয় পর কারো কি এক্সাম আছে?
না স্যার, 5টা বিষয়ের পর আপনাদের।
ওকে, সো এখানে যারা ক্লাসে প্রেজেন্ট নাই তাদের দেখেন, আপনি যদি আপনার প্রবলেম না বলেন, আপনি এক্সামে 10 মিনিট আগে প্রবলেম বলে করে ওটাকে অ্যাকসেপ্ট করা উচিত? বলেন তো। মানে আপনাদের এই সেকশনটা নিয়ে সবসময় এই প্রবলেমটা আমাকে ফেস করতে হয়। এই যে only 32 students in the classroom. আমি জানি না আসলে আপনাদের এই সেকশনটাতে কি সমস্যা। আচ্ছা সমস্যা নাই, আমরা হচ্ছে এক্সামটা একটু তাহলে লাইক 4:25, তাহলে আমরা হচ্ছে আপনার এক্সামটা 35-এ শুরু করলাম, বাট আপনারা 25-এ জয়েন করবেন, কারণ আমি ইনস্ট্রাকশন দেব, বুঝছেন?
স্যার আমার পরীক্ষা আছে স্যার।
কখন কখন এক্সাম আছে আপনার?
বুধবার 6টা থেকে।
6টা থেকে, তো সমস্যা তো নাই। আপনার 4:35-এ শুরু করলে তো শেষ হবে 5:35, এরপর আপনি 10-15 মিনিট সাবমিশন, সমস্যা তো আর নাই মিথি।
আচ্ছা ঠিক
কারণ এখানে মনে হয়
স্যার হোয়াটসঅ্যাপে সহ ভাইবা।
আমি ভাইবার কথা আমি অলরেডি বলে দিচ্ছি, সেটা হচ্ছে বৃহস্পতিবার দিন অল ডে লং ভাইবা হবে, এবং এটা শুরু হবে 9 AM থেকে, এবং আমি সিআর কে বলে দিছি শিডিউল বানানোর জন্য, বুঝছেন? আপনারা যারা শুনেন, আপনারা যারা টাইম মতো এই প্রবলেমগুলো না বলবেন, তাদের প্রবলেমগুলো আমি পরে অ্যাকসেপ্ট করা পসিবল হয় না, কারণ এখানে অনেক শিডিউলিং থাকে। আপনারা ক্লাসে ঠিক মতো জয়েন করবেন না, আপনারা ইনফরমেশন জানাবেন না, এরপর আপনারা হুট করে বলবেন যে আমার এখন ভাইবা আছে, এই আছে, এগুলো বললে কিন্তু সমস্যা। পরে যদি আপনি ভাইবাতে না দিতে পারেন, আপনি 0 পাবেন ডিরেক্টলি, বুঝছেন? এই সেকশনটাতে এই প্রবলেমটা সবচেয়ে থেকে বেশি। হ্যাঁ
স্যার,
সুমাইয়া সুলতানা বলেন।
Sir, I have a lab exam on Thursday from 10 a.m.
ওকে, এটা আপনি সিআর কে বলে দিবেন, যাতে ওই সময়টাতে আপনার নাম না পড়ে, এটা সিআর কে বললেই হবে। কারণ আপনার কিন্তু আপনার রিটেন এক্সামের কিন্তু টাইম আমি চেঞ্জ করতে পারবো না, কারণ রিটেন এক্সাম কিন্তু একটা টাইম স্লট, কিন্তু ভাইবার জন্য দেখা যাচ্ছে যে 4-5 ঘন্টা। সো আপনার এই আওয়ারে প্রবলেম থাকলে পরের আওয়ার আপনাকে স্লট দেওয়া যাবে, বাট রিটেন এক্সামের ক্ষেত্রে কিন্তু এগুলো করা যাবে না, বুঝছেন?
ওকে স্যার।
এভরিওয়ান বুঝছেন? সিআর কিন্তু আপনাদের শিডিউলটা বানিয়ে আমাকে দেখাবে, এরপর আমি আপনাদেরকে শেয়ার করে দেব। এভরিওয়ান, সো আপনাদের এক্সাম কালকে, আচ্ছা মেবি লাস্ট পিরিয়ডের একজনের এক্সাম আছে। হু ইজ হি? লাস্ট পিরিয়ডে একজনের এক্সাম আছে। হ্যালো
স্যার, আমি বলছিলাম আমার এক্সামটা আজ হচ্ছে কি 4:20 থেকে, এবার না 3:20 থেকে।
3:20 থেকে আপনার 3:20 থেকে কত পর্যন্ত?
4:20 স্যার, 4:30 পর্যন্ত সময় লাগতে পারে আর কি ওখানে। 4:35 থেকে শুরু করলে ওকে স্যার আমার
না আমি 30 থেকে শুরু করব, কারণ আমার আগামীকাল বুধবার আমার সম্ভবত ভাইবা। আচ্ছা ঠিক আছে, সমস্যা নেই, ভাইবা 6:30টায় শুরু। না আগামীকাল আমার ভাইবা আছে, কালকে আমি এত লেট করে শুরু করতে পারবো না। এক্সাম 4:30-এ শুরু হবে, ঠিক আছে?
স্যার
আপনার জন্য আমি 5 মিনিট বাড়াই দিলাম, 4:30-এ শুরু হবে এক্সাম।
ওকে স্যার, থ্যাংক ইউ স্যার।
তাহলে তো 10 মিনিট আপনি পাচ্ছেন স্ক্যানিং করার জন্য, ঠিক আছে না? রিয়াজউদ্দিন মোল্লা শান্ত।
জি স্যার, জি স্যার, থ্যাংক ইউ।
তাহলে এক্সাম শুরু হবে 4:30, কারণ আমার আবার কালকে আপনাদের এক্সামের পর আবার সেকশন এইচ এর ভাইবা আছে। তো ওকে, সো শিডিউলিং নিয়ে তো আর কোনো প্রবলেম নাই। হ্যালো
নো স্যার।
ওকে স্যার। এবং আপনারা যদি প্রবলেম না বলেন এবং পরবর্তীতে যদি আপনারা এক্সাম না দিতে পারেন, এটা আপনার পুরোপুরি রেসপন্সিবিলিটি আপনার। মেবি মনিরুজ্জামান হ্যাভ সাম প্রবলেম, হি টোল্ড মি অ্যাবাউট দিস।
ইয়েস স্যার, ছিল স্যার, সলভ হয়ে গেছে
স্যার। কোডটা যদি আবার একটু
স্যার
কোডটা যদি আবার একটু ডিসকাস করে দিতেন।
স্যার একটা কোশ্চেন ছিল স্যার।
ইয়েস প্লিজ।
স্যার যদি এক্সামে কোড চাই, তাহলে তো আমরা নিজেদের পছন্দের ল্যাঙ্গুয়েজ অনুযায়ী তো করতে পারবো।
সরি, পছন্দের
কোড যদি চাই তো C++ এ করতে হবে, এমন তো কোনো বাধ্যবাধকতা নেই।
ওকে, নো প্রবলেম, বাট ওকে
Sir,
yes,
how would you ask question from such transition diagram, sir? Like you will say that draw transition diagram for identifier, or you will give an example, sir?
Sorry?
Sir, I said that how would you ask question from transition diagram, sir?
Okay,
will you direct say that transition diagram for identifier, or will you give an example?
Okay. So if you have proper idea on transition diagram, and then you are able to answer. So how which type of question will come that I can't answer? Okay, if you have proper knowledge on transition diagram, then you are able to answer. Mujumdar Atik.
Yes sir.
আপনি কি আজকে এই ক্লাসে জয়েন করলেন, অনলাইন ক্লাসে?
No sir.
আপনাদের যে কয়েকজনের নাম আমি ডিপার্টমেন্টে পাঠাবো, যারা হচ্ছে রেগুলার বিশেষ করে মজুমদার আগে মনে সম্ভবত 2-1 জন আছে যারা হচ্ছে ক্লাসে জয়েন করে না।
Sir, I just absent was last class and before the last class.
ওকে নো প্রবলেম, বাট আমি ওখানে কয়েকজন আছে আপনার আগে পড়ে, ওখানে ওখানে 3-4টা নাম আছে, ওখানে আমি রেগুলার আমি দেখি তার অ্যাবসেন্ট, আমি এদের নাম চেয়ারম্যান স্যারের কাছে পাঠাবো, আপনাদের কয়েকজনের নাম।
ওকে।
Okay, so this one actually is a transition diagram. Okay, so suppose you need to write the function of this transition diagram. Okay, so this is your transition diagram, and suppose you need to write the function of this transition diagram. So it is very difficult. Everyone listen to me carefully. It is very difficult to write the whole code. It is very difficult to write the whole code in the exam hall, because in the exam hall there is a time constant. Is it? If you think about exam hall, there is time constant, there is a time limitation. So my suggestion, if this type of question will come, so just write the code of the start state, write the code of start state, and write the code of final state with retake. So how many final state with retake? How many?
Sir,
hello,
could you repeat again, sir?
So it is not possible to answer. Maybe possible, but that is difficult. It is very difficult to write the whole code of a transition diagram if the number of states more than 3. Is it?
Yes, sir.
Yes, sir.
Yes. So that time my suggestion actually to write the code of the start state. To write the code of start state, the code of final state without retake. Then how many final state here without retake? How many? How many?
Chatta, sir.
Chatta. That means 2, 3, 5, 7. Then you can choose any of them to write the code. Okay. So you need to write the code of the start state. You need to write the code of a final state without retake. Only one. And you need to write the code of a final state with retake, and there is 2 at final state with retake. So you can choose any of them. Hello?
Okay,
so
sir.
Got my point. So no need to write the whole code. No need to write the whole code. It's enough to write the code of 3 states, and the 3 states are start state, final state without retake, and final state with retake.
Sir, without retake এর কি সবগুলা স্টেপ লিখতে হবে, মানে সবগুলা স্টেট লিখতে হবে?
সরি
স্যার, উইথাউট রিট্রেক্ট এটার সবগুলা স্টেজ লিখতে হবে স্যার।
আমি আপনাকে কি বলে আপনি কি বুঝেন? আমি বললাম যে আপনার যদি এই ধরনের আবু বকর ইজ প্রেজেন্ট হিয়ার। আবু বকর?
নো স্যার।
সো আপনার যে ট্রানজিশন ডায়াগ্রাম তো আপনাকে পুরোটাই ড্র করতে হবে, তাই না? এরপর কোড, যদি এই ধরনের কোশ্চেন আসে যে কোড লেখো, তখন তো আপনি পুরো কোডটা লিখতে পারতেছেন না। মানে অবশ্যই আপনি পারবেন, বাট দ্যাট উইল বি ডিফিকাল্ট ফর ইউ টু রাইট দা, বিকজ এক্সাম হলে আরো কোশ্চেন থাকে। সো এখন আপনি যদি এখন আপনাকে 3টে স্টেট লিখতে হবে, 3টে স্টেট কিন্তু আমি বলে দিচ্ছি। এটা হলো স্টার্ট স্টেটের কোড লিখতে হবে, ফাইনাল স্টেটের কোড লিখতে হবে উইদাউট রিটেক। এখন অনেকগুলো ফাইনাল স্টেট থাকতে পারে যার উইদাউট রিটেক, সো আপনি ওখান থেকে একটা চুজ করবেন। আবার এমন হতে পারে অনেকগুলো ফাইনাল স্টেট থাকে উইথ রিটেক, সো আপনি ওখান থেকে একটাকে চুজ করবেন।
ওকে স্যার।
Got it everyone?
Yes sir, got it sir.
So everyone got it? So any question regarding with the code, please ask.
স্যার কোডটা একবার দেখাই দিলে ভালো হয় স্যার, এইটার দিয়ে তো বুঝাই দিলে ভালো হয় স্যার।
কেন কোড আমি একবার বুঝাইছি না ক্লাসে? আপনি ট্রাই টু আস্ক স্পেসিফিক কোশ্চেন। Okay, please ask question from this code.
স্যার উইথ রিট্রেক্ট বলতে কি বোঝাচ্ছেন একটু যদি বলে দিলে ভালো হতো স্যার।
উইথ রিট্রেক্ট মানে যেগুলোতে স্টার আছে, যেখানে রিট্রেক্ট করার প্রয়োজন হয়, দ্যাট মিন্স ওয়ান ক্যারেক্টার পুল ব্যাক করার যেখানে প্রয়োজন হয়, ওইগুলো হচ্ছে উইথ রিট্রেক্ট।
স্টেট 8 হচ্ছে স্যার রিট্রেক্ট।
ওকে স্যার।
With retake means there is a retake means actually you need to come back, you need to pull back one character, and to indicate retake in transition diagram we put asterisk. Is it?
Yes, sir.
Yes. So please ask question from the code. Hello.
No question, sir.
No question. That means this one is easy. So that means you understand this one.
Easy, sir.
Okay, just I want to explain only two. Okay, just two step. Okay. Okay, so think about the start state. So when so we know that actually, just a minute. So we know that actually why here we actually use case. Here we use case
Sir.
to represent a
Sir.
state. Yes, please.
স্যার যদি প্রথম দিকে যদি এই ফাংশনগুলো ক্রিয়েট করা হয়েছে টোকেন গেট ট্রি লুপ, স্যার স্ক্রিনটা দেখা যাচ্ছে না।
Yes.
প্রথম দিকের এই যে স্যার যে ফাংশনগুলো নিয়ে হয়েছে টোকেন গেট ট্রি রিলুপ, তারপর হচ্ছে টোকেন ইকুয়ালস টু নিউ রিলুপ, এই দুই তিনটা লাইন যদি একটু বলে দিতে মানে ডেসক্রাইব
Okay,
করে দিতে।
so this one actually, this is the function name, and the function name is get reload, and this is the actually the return type, and return type is token, and token has two components. The first one is token name, and second one is actually attribute value. And for this one, the token name same, that is the reload. That's why at first I assign the first component. I said the first component. Okay. So this part is common. This part is common. You must need to write this part. This part you must need to write. Everyone, this part you must need to write.
Comments is not meant
এটা কি সবগুলো ট্রানজিশন ডায়াগ্রামের কোডের জন্য সেম হবে?
এটা আপনি সেম হবে কি এটা আপনি চিন্তা করে দেখবেন সেম হবে কিনা। এটা কিভাবে বলবো?
স্যার
কমেন্ট ইজ নট ম্যান্ডেটরি। কমেন্ট ইজ নট ম্যান্ডেটরি। ওকে। এখন আপনি সবগুলোর জন্য সেম হবে কিনা এটা তো আমাকে এই ধরনের কোশ্চেন করেন কেন? আপনি বুঝেন না, আপনি কোড প্রোগ্রামিং কোর্স করছেন না?
স্যার এখানে হচ্ছে টোকেন নেম হচ্ছে সব ক্যাপিটাল লেটারে লিখছে।
Normally the token name actually is written in capital letter. Okay. So suppose then we know that actually each state is represented with the help of case. So case 0 is represented state 0 is represented with the help of case 0, is it?
Yes, sir.
So then we actually read the next character. If the next character this one, then the state is 1. If the next character is equal, then the next state is 5. If the actually next character this one, then the state is 6. So if the c is equal this one, that means state 1. If c is this one, that means state 5. If c is this one, then state 6. Otherwise fail function. Okay. Otherwise fail function. Okay. So now I'm going to discuss this one, and this one actually a final state without retake. So this one actually case 2, is it? So now this is the case 2. So case 2. So if you consider this one, so no need to retake, is it? If you consider case 2, no need to retake because there is no retake in state 2, is it?
Yes, sir.
Yes, sir.
Okay. So there is no retake, so no need to call retake function. Now at state 2, you need to actually set the attribute value, that is LE, that means less or equal. Okay, but the first one is already actually assigned at the very beginning. The first one is already actually assigned at the very beginning. So you need to put the attribute value, that is actually LE. So return token dot attribute, that is LE, that is the second component. Then you need to return. Okay. Hello.
Okay, sir.
Okay. So think about a final state with actually retake. So that is the like state 4, and state 4 is represented with actually case 4. So go to the case 4. So case 4, that means at first you need to call retake. This one. So at first you need to call retake. Then you need to set the attribute value, that is actually LT for state 4. This is the actually attribute value. Then you need to actually return the token. Okay. And as in the exam, if this type of question will come, you need to write the 3-state code. So you need to put dot. Suppose if you write case 0, that means case 0, then dot dot, then case 2, then dot dot, then case 4, then dot dot. Okay, because there is also many codes, but you write only 3. That's why you need to put dot dot. Okay, and this part, so this one actually you need to write, because this is actually part of the structure of the program. Okay, everyone?
Okay, sir.
I mean, same thing, how many times I will repeat? Someone please repeat it again and use English to repeat it. Someone please repeat it.
First step will be
Hello?
it's mean case 0 will be. Yes, sir.
Okay, so
Yes, sir.
you need to write the state of 3 codes, and the 3 states are start state, final state without retake, final state with retake. And maybe you have more than one final state with retake, then you choose only one from that one with retake. And if you have more than one final state without retake, then you can choose only one from them. That means you need to write 3 state code: initial state or start state, final state without retake, final state with retake. So got it, everyone? Now?
Yes, sir.
Hello?
Yes, sir.
Yes, sir. Yes.
Okay. So, okay, just a minute. So I actually, this is this transition diagram actually for operator type.
Sorry, sir.
Like operator.
Yes,
This
sir.
transition diagram for like operator. Okay, just a minute. And here actually I use the token name is reloop, because this is actually relational operator. But if the different types of operator, like in the we practice one, like this one, maybe this one, is it we practice this one, is it in the class?
Yes, sir.
Yes. So that time the token name may be different, like you can use like just operator token name. Okay, that is not reloop, that is like you can use operator as token name. Okay, hello?
Okay, sir.
Okay, sir.
স্যার কিওয়ার্ডের ক্ষেত্রে এই যে
Okay, I will discuss about keyword now. Actually the code for I think just a minute, I think I discuss, oh just a minute. Yes, suppose I think I discussed this one in the classroom, that is the const, continue, character and case, is it?
Yes, sir.
Yes, sir.
yes sir.
Yes. Okay, so actually, so if you think this one, so I just modify the previous code. I just modify the previous code to write the code of this transition diagram. I just a minute, I just modify the previous code to write the code of this one. So actually there is 21 states, and it is very difficult to write the code of each state, is it?
Yes sir.
Yes, sir.
And for this also you need to write the code of 3 state, but there is some little bit change. If this is actually keyword transition diagram, that means all the final state should have retake. Okay, as this is actually transition diagram of keyword, that means actually all final state has retake, all final state has retake. So but you need to write the code of 3 state, is it? So that time you need to choose start state, then final state with retake. So you have 4 final state with retake, you can choose any of them. Then you need to write the code of any state, like 1 2 3 4 5 7 8 9, like that. So you can choose any of them. Okay, hello?
Okay,
Okay, sir.
Now it is, that means for key type keyword type transition diagram, you need to write the code of the start state, final state with retake, and then any other state. So you can choose 2 state, no problem. And if you choose 2 state, that is easy. But if you choose 1 state, that is actually you need to write more code. So like that. So just I want to explain this code. So this is the same, this one is same. Now, so so keyword has attribute value or not?
Sorry, sir. Could you repeat again, sir?
Keyword has attribute value or not? Keyword has attribute value or not?
Sir, attribute don't have sir attribute value.
Okay, so that's, and that token name of each keyword is different. But if you consider the previous transition diagram, though their transition diagram for actually a relational operator, that's why the token name is same. But as this transition diagram for keywords, that means the token name is different for different from one another. That's why here I don't actually assign the first component. Here I don't assign the first component, but in the previous case I assigned, that is reloop. But for keyword, no common actually token name, because if there are 4 keywords, that means there is 4 token name, and the token name actually just the keyword but in the capital letter. Okay, that's why I don't actually assign the first component, okay, for this transition diagram. Is it, everyone?
Okay, sir.
So if you think about the first state, that is the actually 0 state, that means case 0, and okay, so this is the actually case 0, and C actually is used to scan the next character. If the next character is C, the next state is 1. The next state is 1. So that's why there is actually 1. Okay, and otherwise fail or break. Okay, so one thing is actually different. If you consider this code, you need to actually call fail function repeatedly until you will get the final state. Because suppose this one, if you consider this, suppose, just a minute, suppose this one. So if you get the first character, so I think the first character is enough to be a relational operator. This one is a relational operator. If you don't get this one or this one, but no problem, still this one actually relational operator. Is it?
Yes, sir.
Yes, sir.
That's why if you consider the previous code, just fail actually is called only one time. But if you consider CH, so this one is, you can consider, so based on the first character or second character, is it possible to say that this one actually keyword?
No, sir.
Until the last one. So suppose CHA, still it is not possible to say it's a keyword. Suppose CHAT, chat. So chat is actually not actually keyword. Okay, it's an identifier. So until you get the final state, you are not sure this one is keyword. That's why you need to actually call fail function in each state until the final state. Okay?
Yes, sir.
Okay. So think about state like 1. If the next character is 0, that means state 2. If the next character is actually A, that means state 13. If the next character is A, that means state 17. So go to the case 1, that is next character is if O, that means state 2. Next character is, that is state 13. Next character is A, that is actually state 17. I will not share this file. So everyone, please listen to me carefully. If needed, please write down. And then else file. Okay? Then else function. Okay? Hello?
Okay, sir.
Okay. So then think about a final state like this one. This is the 6th state. That means case 6. So at first, you need to actually call the retake. So you call the retake. Now the token name. So token name actually for keyword, the token name is same, but in capital letter. So CONST. So if I consider capital letter CO capital NST. So this is the token name. But previously we said at the before token name, but now here I actually assign token name CONST, and the attribute value is null. But previously actually we said attribute value, but for this transition diagram the attribute value is null. But for the previous one we said the attribute value and we said the token name at the very beginning. But for this one we said token name as like the actually keyword, just the in the capital letter, and attribute value is null, because we know that actually for keyword there is no attribute value, and then we simply return. And here I use dot dot because after 6 I write 12, then also I write dot dot because there is also many quotes. Okay, everyone got
Okay,
it?
sir. Yes.
Got it?
Yes, sir.
Got it? Okay. So okay, now if you have problem from midterm syllabus, then please ask.
Sir, input buffer.
Input buffer.
Yes, sir.
Yes. Okay, maybe someone said me to share the updated file of actually panic mode recovery. Is it? Hello?
Yes, sir.
But
Example গুলো স্যার নাই।
but I will not share. আপনারা কি লেখেন নাই? নোট করেন নাই? হ্যালো? আপনারা কি নোট করছেন? হ্যালো? আচ্ছা, আমি আপনাদেরকে নোট করার জন্য আজকে টাইম দিচ্ছি, জাস্ট 2 minutes or 3 minutes আপনারা নোট করবেন। ওকে
ওকে স্যার, প্লিজ স্যার।
জাস্ট a minute. Okay, as this topic actually is taken actually using actually online, that's why I just shared this. Okay, if it is physical, that time I will not share. Okay, hello, just I will give 2 or 3 minutes to note down. Okay,
Okay, sir.
Okay, sir.
still the slide is incomplete. Still the slide is incomplete, and you need to add many things by you if you think about example. Okay, just a minute, I want to share. So actually just a minute. So this is the actually, just a minute. So this is the actually the example of panic mode recovery, but here I use like line throw cut, but you need to cut like this one, like one by one. Okay, like this. You need to cut like this. Okay, everyone. Hello.
Okay, sir.
Okay, so
Yes,
so you, because we know that in panic mode recovery only one character is discarded at a time. That's why you need to cut like this, not this one. Okay. So this one is different. Okay, so you need to cut like this. Everyone got it?
Yes, sir.
Okay, so this one. Okay, then phrase level recovery, it is okay, no problem, because there is no semicolon, then simply put semicolon. There is comma, just this comma is replaced with semicolon. Is it? Hello. So done.
Sir. Yes, sir.
Okay, can I change this slide? Hello.
Yes, sir.
Everyone, can I Isha, can I change this slide?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
And here actually there is a grammar, and this is the input ABCD, and it is not possible to actually generate this input with the help of this grammar, but the parts tree is not actually in the slide, but you need to draw the parts tree also. Okay, you need to draw the part. If you want to give the example of error production, that time you need to draw the parts tree, but the parts tree is not present in the slide. but at the time of discussing this topic, I actually draw the parse tree. Okay, so you need to draw the parse tree also. So this grammar is not enough to generate this input string. That's why you augment this grammar to this grammar. Okay, and here you need again draw the parse tree. Okay, so you need to draw the parse tree for this input, for this grammar, and you also need to draw the parse tree for this input for this grammar. That means two parse tree you need to draw, and those parse tree is not present in the slide. So it need to be done by yourself, because I already discussed those. Okay, everyone.
Okay, sir.
Got it? Then note down complete. Hello? That means
Yes, sir.
with the help of this grammar, it is not possible to generate this one. Okay, so you need to write this one, you need to write this input, then you need to draw the parse tree. Then you augment this grammar to this grammar, so that you are able to generate this input. Is it? So again you need to draw the parse tree for this grammar and for this input. Okay, everyone. So can I change?
Yes, sir.
Okay. And global correction, global correction actually no nothing actually example, but at the time of discussing this topic I give example. Suppose there is a grammar G and there is actually input string X, and this one is actually incorrect, and you are trying to make it correct. So suppose the first algorithm needs 10 and 10, then the second one needs like 8, and the third one needs like 3 operation. Because in global correction, the main focus is actually minimum number of operation. If you think about global correction, then your main actually focus actually minimum number of operation. So you have a grammar G and you have incorrect string that is X. Now you need to make a correct string that is Y, and if you and there are multiple way to correct incorrect string X to correct string Y, and the first one requires 10 operation, second one requires 8 operation, and third one requires 3 operation. And global correction method actually choose this one, because this one need minimum number of operation. Okay, got it, everyone? Hello?
Yes, sir.
Okay. So now please if you have any question, please ask one by one. So Isha, what is the problem for input buffering?
স্যার আরেকবার যদি রিমুভ করতেন এটা সিম্পলি আর কি।
Okay. So is it visible? Hello?
Yes, sir.
Okay. So suppose now, just a minute. Okay. So this is your input buffer. So you can start from here, no problem. You can start from first position. So suppose, just a minute. Okay, so suppose the length of the actually buffer is 10. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10. But then we need another cell to indicate this is the last of the buffer. That is EOF. That is sentinel. Okay, so the buffer size is 10, and the last one is used to indicate this one actually the end of that buffer. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So buffer size is 10, okay, and the extra cell is used to indicate this is the end of the buffer. Okay, suppose my statement is EE MM then CC square. Suppose this is my, and last like this one, okay? Then at first E, then again E, is it? Then there is a white space, so white space, then this one, then again white space, then MM, then this one, then C, then this one, then 2, then okay. So your input is done. Then that means again UF, is it? Hello?
Yes, sir. Yes, sir.
Yes.
Sir, white
So,
space keno debo?
Because in statement there is white space.
Oh.
There is a white space. Okay. If white space is not given in the statement, no need to put white space. Okay.
Yes, sir.
Okay, sir.
Okay.
স্যার এই অ্যাসাইনমেন্ট অপারেটর যদি থাকে স্যার যেভাবে আছে ওইভাবেই তো লিখবো না?
Yes.
Okay.
And you need to write according to the question. Okay. So at first the legsym begin there, and actually your forward pointer is there. Okay. Then your forward pointer just move. So there is E. So it is not possible to take decision by observing A. So your forward pointer now here. That is actually forward pointer. So E after D, it is possible according to the pattern, no problem. Then your forward pointer here, but there is white space. So it is not possible according to the actually pattern. So this actually E is a valid legsym, is it?
Yes, sir.
Okay. So consider this one. So this one, that means legsym begin here and forward pointer also here. Then star, that means stars, it is not take decision because star means this one or this one. Okay, so you need to observe the next character also, that then the forward point character here, there is another star. So it is possible according to the pattern, star after star. But if you again forward, there is 2, but according to the pattern it is not possible. So actually the valid legsym actually from so what is the legsym begin? This is the legsym begin, and now forward pointer here. That means you need to actually just look at the back. That is actually this one and this one. This one actually a valid legsym. Okay. Hello.
Yes, sir.
Okay. So
Yes.
I have also another concern about input buffering. So it is not possible to explain the whole buffer process in the exam hall because it is very time consuming, because there is many actually legsym. So so if you explain only one from same type, that is enough. Suppose there is EE, MM and CC, those 3 are same, so you can explain only one from them. Then suppose there is multiplication and double multiplication, that means exponential, both are same, so you can explain only one from them. Okay. Then there is number, so you can explain this one. So if you explain 2 or 3, that is enough. If you are able to explain 2 or 3, that means you are able to explain the whole. Okay, got it? So no need to explain all those things because it is very time consuming to discuss all of those. So it's enough if you explain 2 or 3, and 2 or 3 actually should be different, not same type. Like if you consider, just a minute. So if you consider like position equal to initial plus rate into 60. So suppose this is your statement. So there is actually 3 identifier: position, initial and rate. So if you explain only one from them, that is enough. No need to explain 3 because the process for those 3 is same. Then if you explain this multiplication, so you can choose this multiplication. Okay, no problem. So that time no need to choose this assignment because the process of describing multiplication and assignment same. Okay, so you can explain 60, no problem. So if you have same type, then you can explain one from them. That means if you explain 2 or 3, that is enough. If you explain 2 or 3 valid legsym, that is enough.
স্যার স্ট্রিং থেকে একটা, ডিজিট থেকে একটা, সিম্বল থেকে একটা, এরকমই তো স্যার?
actually it's totally depends on you actually, but মানে এই চুজিংটা কিন্তু আপনাকে করতে হবে। দেন আমি কিন্তু আপনাকে সবই বলে দেই, তাহলে তো আবার সমস্যা। মানে আপনি স্টুডেন্ট হিসেবে তো আপনার কিছু ক্যাপাবিলিটি থাকতে হবে। আমি তো বলে দিলাম যে সেম টাইপ হলে ওখান থেকে একটা একটা করে নেবেন। যেন কেউ একজন কোশ্চেন করছিল আগের বার যে কোডের এই পার্টটা কি সব ট্রানজিশন ডায়াগ্রামের জন্য সঠিক হবে কিনা। এখন যদি আমি যদি হে বলতাম তাহলে কিন্তু এর একটা সমস্যা, কারণ অনেক ট্রানজিশন ডায়াগ্রামের জন্য হয়তো সেম হবে না। তো এটাকে আপনাকে এটা চিন্তা করতে হবে যে আপনার যেটা লিখতে হবে ওখানে কি সেম হবে নাকি একটু ডিফারেন্ট হবে, সেটা আপনার, কারণ ওয়ার্ল্ডে কিন্তু ম্যাক্সিমাম জিনিস মানে জেনারেল ভাবে বলা একটু টাফ। মানে আপনি জেনারেল ভাবে 2-3টা কেস মিলাইতে পারবেন, বাট সব কেস কিন্তু জেনারেল ভাবে মিলানো যায় না। এই জন্য কিন্তু স্পেশাল একটা ওয়ার্ড আছে, বুঝছেন? তো আপনি এই ধরনের কোশ্চেন আমাকে করবেন না, আমি বলে দিছি। এরপর আপনি আপনার ব্রেন খাটায় এরপর ভাববেন কোনটা কোনটা করা যায়, বুঝছেন? হ্যালো?
জি স্যার।
Yes, sir.
Yes, sir.
Okay. So any question from input buffering?
No.
আমি আপনাদেরকে যখন এই টপিক পড়াইছি সবসময় আমি কোশ্চেন সাথে বলে দিছি যে কি টাইপের কোশ্চেন আসতে পারে। তো রিভিউ ক্লাসে কি ধরনের কোশ্চেন আসবে এটা আমি কিছু বলতে পারবো না। আপনাদের প্রবলেম থাকলে আমাকে বলেন, আদারওয়াইজ আই উইল স্টার্ট। কোনটা? আমি তো এইমাত্র ইএমসি স্কোয়ার দিয়ে বুঝাইলাম, আবার কি বুঝাবো? আমি বর্তমানে এটা বুঝাইলাম না আপনাকে, এটা বুঝাইলাম না আপনাকে, তাহলে আপনার আবার কি বুঝাবো? আমি তো এইমাত্র উপরে ড্র করে এটা বুঝাই দিলাম। হ্যালো? সবগুলো তো সেমই, জাস্ট আমি যদি সিম্বল চেঞ্জ করে দিই তাহলে এই বাফারের এখানে সাপোজ আমি ইউজ করলাম এম, তাহলে এখানে ই এর জায়গায় এম লিখতে হবে, লাইক দ্যাট। এভরিওয়ান গট ইট? হ্যালো?
Yes, sir.
Okay. So any question from midterm syllabus? Otherwise, I will start a new topic that is follow. Then tell me your problem from midterm syllabus. Otherwise, I will start a new topic. হ্যালো?
স্যার মিড টাইমের সিলেবাসটা থেকে রিভিউ করে দিতেন, মানে প্রথম থেকে।
নো এইভাবে আমি রিভিউ করব না। আপনারা প্রবলেম বলেন আমাকে, প্লিজ টেল মি দ্য প্রবলেম।
স্যার এখানে যে ই ইকুয়ালস টু এর আগে পরে স্পেস আছে, এরকম সব সময় দিতে হবে?
যদি আপনাকে যে সাপোজ দ্য কোশ্চেন ইজ সাপোজ এক্সপ্লেইন বাফারিং প্রসেস বাই ইউজিং দিস স্টেটমেন্ট, so if the statement has white space, that time you need to put white space. If that statement don't have white, suppose this statement like this, just a minute. So just a minute. So this is the like this one, E, just a minute, M, C square. So you can easily understand that there is a white space, there is another white space, but there is, just a minute, so there is no white space between M and into, there is no white space actually between actually C and this into. But suppose this one, so is there any white space? So sometimes at the time of writing code, we put white space before and after operator, and sometimes we don't put. So if in the statement there is white space, that means you need to put white space. If the white space is not present, that time no need to actually write white space, no need to actually put white space. Okay. So if you observe the statement very carefully, you will be easily actually understand that there is white space or not. Okay. If white space, that means there is a little bit actually space. If no white space, that means no actually space. Okay. And by observing a statement, you can easily understand there is a white space or not.
Okay, sir.
Okay. Then, hello?
Yes.
No question? No question from your side? Hello?
No, sir.
Okay, that means all of you actually will very well in the actually midterm exam. I hope. Is it?
Inshallah, sir.
So give your attendance. And do you know the syllabus of the midterm, everyone?
Yes, sir.
What is the last topic? What is the last topic of your syllabus?
Sir.
Representative grammar.
Is it representative grammar, sir?
স্যার রিপ্রেজেন্টেটিভ গ্রামার তো স্যার মিড টার্মে নেই, সেটা তো ফাইনালের জন্য বলছিলেন।
সরি
স্যার রিপ্রেজেন্টেটিভ গ্রামারের মানে রিপ্রেজেন্টেটিভ গ্রামার যে টপিকটা ওটা তো ফাইনালে আসবে না, এটা তো মিড টার্মে দিবেন না বলছিলেন।
লেফট রিকারশনের আগ পর্যন্ত আপনাদের সিলেবাস আছে। লেফট রিকারশনের আগ
ও
পর্যন্ত
হ্যাঁ
কি
হ্যাঁ
আছে
স্যার,
বলেন তো?
ঠিক আছে।
লেফট রিকারশনের আগে কি আছে বলেন তো? হ্যালো,
স্যার ambiguity.
Just a minute. I need to check.
Leftmost, rightmost ওগুলা maybe.
That means this slide is the last slide. Just a minute. This one is the last slide. Okay. Hello? This one is the last one. Okay.
31 slide.
Yes,
I don't
sir.
know because this slide actually I modified multiple times and I don't know that the page number is same like the slide that I posted. But this is the last one. So there is also representative grammar, but there is actually term left recursive. That's why those are actually not part of your midterm syllabus. Okay, but this one is the part of your midterm syllabus. Okay, so make it easy. So the last topic is ambiguity. Okay. Hello.
Okay, sir. Thank you, sir.
Okay, sir.
So ambiguity is the part of your mid syllabus. That means before left recursion, that is your syllabus. Okay. Everyone.
Okay, sir.
Okay.
এটা অ্যাভেলেবল আছে ভাই ক্লাসরুমে।
সিনট্যাক্স অ্যানালাইসিসের চ্যাপ্টারটা দেখ।
Okay, everyone, please give your attendance. Okay, Khondokar Fahim.
Yes, sir.